In this video, we're going to solve some logarithmic equations. We have seen some before in previous videos. These are going to require a little bit of isolating the log, but also recognizing the different types of logs like natural logs and common logs. So here on the right hand side, I have 3 plus 3 times log base 3 of x minus 1 equals 15. So to get this x out of this log, we're going to have to do the inverse. The inverse of a log is an exponential. But before I can do that, I must isolate the log. Do not add 3 plus 3. You can't do that because of this times. So first thing, we have to get rid of the 3. Subtract 3 from both sides. I'm left with 3 times log base 3 of x minus 1 equals 12. Again, I have to get rid of this other 3, undo that operation with division. Now I have log base 3 of x minus 1 equals 4. Now that this is totally isolated, I can undo the log. So undo logs, we use exponents or exponential form. So I have to rewrite this exponentially. Start with the base. The base is 3. Logs equal exponents. So this log equals 4. The exponent is 4. That will equal the only thing we haven't used yet, x minus 1. And then lastly, I need to get x alone, so I'm going to end up adding 1 to both sides. 3 to the 4th is 81, and then 81 plus 1 would be 82. So x equals 82. And this is something that you could plug in and then evaluate and make sure you get 15. This next example has the natural log of 5x equals 27. And this is where we have to remember that the natural log is the same thing as log base e of 5x equals 27. So some people do not have to write this step, and that's okay, as long as you remember the natural log is base e. So again, to solve a logarithmic equation, I'm going to do the inverse, and the inverse is to rewrite it exponentially. So start with the base. The base is e, in exponential form. Logs equal exponents. The exponent is 27. That will equal what we took the log of, 5x. And then I want to get x alone, so I divide by 5. Now my guess is your homework or something like this would make you leave it in this exact form, because it's going to be a quite large number. Let's plug it in and check it out. If I did 27, took e to that power, look at how big that number is. I could divide by 5, but it's still quite a large number. So my guess is that your homework would ask you to leave it in this form. Same with a quiz or a test. Alright, it's a very big number. I would like you to try the 2 examples on the right hand side. Let's see how you did. First one, the log is isolated. The only thing I have to do is undo the log by rewriting it exponentially. Start with the base. The base is 2. Logs equal exponents. The exponent is 5. And then that will equal what we took the log of, 3x plus 1. 2 to the 5th is the same thing as 32. And then we still need to solve for x. So I subtract 1 from both sides. I get 31 equals 3x. and then we divide by 3. So the exact solution would be 31/3. And then if you're asked to round it, 31 divided by 3 is 10 1/3, or 10.3 approximately. So that's the approximate. And this is the exact. Alright. The next one says log of 5x minus 3 equals 2. Now wait a minute, there's no base. What do I do if there's no base? That means it's a common log. So this is the same thing as log base 10 of 5x minus 3. And now I can rewrite it exponentially. So the base is 10. Logs equal exponents. So the exponent will be 2 equals 5x minus 3. I'm going to simplify. 10 squared is 100. I want to get x alone, so I add 3 to both sides. This is now 103 equals 5x. Lastly, divide by 5. So the exact answer would be 103 divided by 5. And then, oops, exact. I can put that in my calculator. 103 divided by 5 is 20.6. So that would actually be exact as well, because that's a nice decimal. And there you go. I didn't round anything, so these are both exact answers.